So we have one more thing, as the famous quote goes. On June 25th, we're going to change our support statement from this to this, which will add ARM64 support to Ceph for clients for the first time in a while. We haven't had major vendor supporting ARM since SUSE exited the picture 5 years ago, so this was just about time. ARM is cool, but we aren't doing this just because it's cool. As a product manager, I like to have a shot at actually producing revenue out of the things I do. And I think that we've reached the point where we can actually be excited about building a business around ARM. It's not just fun from the engineering perspective. So this is our timeline. What you want to focus on is below the line, because there is too much detail in this slide. So ARM client GA will be in a couple of weeks this month. We're working to reopen the community lab that has been migrating between Red Hat facility in North Carolina to an IBM facility in Arizona. And when that reopens, we'll have access to the ARM hardware that Ampere has donated to the lab. We are aiming for support of ARM-based clusters by the end of the year. This also cascades throughout the IBM product line. So this is support statement for IBM Ceph, Red Hat Ceph, OpenShift Data Foundation, and where the clients are concerned, Red Hat Enterprise Linux. So it may be in more places, we'll see. There are 15 places where we ship Ceph between the product lines that IBM controls. But those 4 are definitely going to ship ARM. So what are the implications? There are a bunch of things that we still have to do. Community lab reopening first and foremost. But we need to also be at a point where Tautology runs regularly against ARM, and not just x86. After that, we need to tune for ARM in terms of making Ceph work optimally there. And then possibly even supporting acceleration extensions on ARM, like we do currently for Intel QAT, for example. That would be a second stage of optimization, which may or may not be interesting. We'll figure that out when we get there. Another thing that we need to do is have some sort of reference architecture for people to design clusters based on ARM to start with. And there are a few more things that we need to do, part of our normal community process, like having a designated community contact, a PTL, regular meetings, things like that. So we have a lot of stuff to do, and that's where we're going. But we're also being very transparent about what needs doing. So as our friend Ken Dreyer likes to say, patches accepted or volunteers accepted. If anybody wants to contribute, we are very interested in getting help. Now, as I said before, I'm very serious about this as a business, but when somebody says ARM, what you guys are hearing is Raspberry Pis. So this is the cluster that I demoed at KubeCon with Sebastian Hahn in 2019, and those of you that were there will remember failed. It didn't fail because it was ARM, it failed because of power supplies, but there are plenty of surprises when you introduce something new. We do support power as part of the IBM and Red Hat products, and we discover very exciting and interesting bugs there that we absolutely do not expect. We think that ARM will produce just about the same. To give you a little bit of a tip into what may be interesting if you want to build a home lab, these would be my recommendations. So for some reason you work for Red Hat or IBM, obviously it makes sense to have a home lab based on RHEL. But if you are hacking your Ceph cluster, Ubuntu, Debian, Fedora are the obvious choices for that, depending on what hardware you're actually using. One less known option is Armbian. Armbian is a fork of Debian that has old sort of drivers for SBCs. So if you're building your home lab cluster using SBCs, Armbian should be on your list. This doesn't mean that these will be supported by our enterprise products. So on the nope list is don't ask me for support on a Raspberry Pi cluster. The answer is no. And now Peter has a significant result to share.
Hi, everybody. Well, first of all, I'd like to thank Federico for inviting me today to help talk about this. So Ampere over the years has done some preliminary testing of performance of Ceph clusters, both on Ampere Ultra-based platforms in the past, and we've released those as blogs and white papers that you can find on our site. So as one of the things we did prior to this event, we took some of the inventory of hardware we had in our lab to essentially build a Ceph cluster and run it through the paces to compare it against what we did on the Ampere Ultra-based platform versus Ampere 1. For those who are unfamiliar, the Ampere Ultra-based platform is a Neoverse core versus an Ampere Ultra, which is actually Ampere intellectual property as the core, both ARM64 compliant. So this is what the cluster setup or the hardware that we used to test with. It was literally what we had in our lab that we had been using for other things. So it was, we didn't actually have the time or let's say energy to really put much thought into like a real architectural. This was a kick the tires exercise. So, and this is, a little more details. We had, 3 hosts, 3 monitors, 2 managers, 24 OSDs, 4 pools. And, that's just the basics of what we were kicking the tires on. So, did I go backwards? Cluster inventory. That. Okay. So what do we got? Well, first off, we got 4 KB random writes reached a maximum of 400,000 IOPS on Ampere 1 compared to 200,000 IOPS that we had achieved with Ultra in the past. And we used REPL 2 on that with NVMEs. So we obviously had a greater increase in the level of IOPS we could push, which is great. And then we go into read performance. We were actually able to saturate the disks with the cores. So that's actually, also a great thing. So, from that perspective, we actually saw, some better performance with the Ampere 1 versus the Ultra. And then this graph shows the incremental performance and latency versus the OSDs. You can see we got a little better there. And then, we really took a step back, and there was an article that was published in January. I believe it was the Clyso folks who did that work. That was the cluster that they used, and we said, okay, we'll take our numbers and compare them to what they were able to do on their cluster, and we were able to achieve similar performance in IOPS comparatively using the Ampere 1. And you can see we broke the numbers out in both a REPL 2 and a REPL 3 scenario. So in terms of power consumption, with 4 Ampere Ultra nodes, we were able to deliver about, like I said, 200,000 IOPS while consuming around 900 watts. And with 3 Ampere 1 nodes, we delivered 4,000 IOPS while consuming 1,430 watts. So what that really means is we've achieved a better IOPS per watt performance. And you can see here, we got better IOPS per watt with the Ampere 1 versus the Ampere Ultra. And we are fairly optimistic with what we're seeing initially, that we should be able to drive more disks. We just didn't have the disks on hand to test. So as I mentioned earlier, all the nodes that we tested in this configuration of the Ampere 1 had 8 disks. So that all being said, it's looking pretty promising. As I said, this was just us kicking the tires, but it's I would say it's very optimistic, and we're excited to continue to work with IBM and the rest of the community to see if we can help get better performance for our workload on Ceph. And that's it. So thank you.
And if any,
Go ahead.
yeah. So what are the relative processes between Ultra and Ampere One? What are geometries?
That's a good question. That might be over my head. Like I said, the key difference is in Ampere One, it's Ampere intellectual property in the core. So we have a smaller core, higher core density, more efficient core than the Neoverse 8.4, 8.2 cores that are in the Ampere Ultra by process. No. So yeah, if you want to, I didn't run the test, so yeah, what we can do is I would love to chat more and we can have a discussion with the engineers later. Awesome. Thanks. Anybody else have any questions? Great. Well, thank you. And I'm around all day if anybody has further questions or would like to know more about Ampere. Thank you.